Professional cycling can be one of the most intense sporting tests, as road and track cyclists push their bodies to the limits. As well as being in peak physical condition through diet and training, these cyclists want to ensure they have the best possible technology at their disposal. They want bikes and clothing which make them as aerodynamic as possible. In this episode of our video series on the science and technology of professional sport, we are taking a look at cycling. We are at the Centre for Sports Engineering Research at Sheffield Hallam University in the UK. Part of the work that goes on here is to study the mechanics of sport and to apply this knowledge to design sports equipment.
Well, we start with the physical principles of the thing that we're looking at. And the bike is a fantastic one to look at because you've got an isolated bike with the athlete travelling over a surface. So looking at the physics of it, you've got the power output of the athlete driving the bike forwards. And then you've got the energy losses trying to slow that cyclist down. So as a physicist and as a sports engineer, the thing that we're trying to do is to reduce those energy losses wherever we can. So we look at those and they might be the aerodynamics is by far the largest one. So we can look at improving the aerodynamics, we can look at improving the cross-sectional area or reducing the cross-sectional area of the athlete and the bike as a whole. Then we can look at things like the bearings, improving the efficiency of the bearings. We can look at the efficiency of the crank system, of the chain. And also we can look at changing the materials of the bike so that the bike doesn't deflect quite so much every time the pedal is turned. Because every time something deflects, you tend to lose energy. Well, this is a road bike, and the first thing to know about bikes is that anything that sticks out into the air is bad because it's going to introduce aerodynamic drag. So the handlebars is one of the first things that you see sticking out into the air. So what we have here is we have an aerodynamic shape here. We've got these handlebars designed to force you to put your elbows into the bars, and that brings your body down so you're looking forwards. That reduces your cross-sectional area and reduces the aerodynamic drag as well.
So what's this actually made from? Because it feels very light, almost like plastic or something.
Well, this bit at the front is made out of carbon fibre, and that allows you to have relatively complex shapes. We've got a nice aerodynamic shape here at the front to make it very efficient as it goes through the air.
Is that just because it's easier to mould? So
yeah, it's easier to mould. You've got carbon fibre comes up in layers, so you can get these complex shapes, something you couldn't do with a traditional tubular metal frame. So then what we have is we have the rest of the body which you can have in relatively complex shapes. This one's actually made out of aluminium, but it's very lightweight. And then energy losses come in all the other parts of the bike as well. So here you've got the wheels, again made out of carbon fibre here. Now these tyres aren't pumped up, and you can see how much they deform there if they're not pumped up. And if you've got anything deforming, you're losing energy as it's in contact with the surface. So the idea behind these are you have a very narrow tyre, you have tyres that are as large as possible, and you also pump them up as high as possible to reduce those deformations.
So that's designed for a smooth road and a smooth surface?
Yes, a smooth surface. If you're on a mountain bike, you'll see that they have knobbly tyres because you need more traction and you need much lower speeds. But those knobbly tyres are terrible for rolling resistance. And if you've got a bike like mine, you're trying to cycle it on the roads outside, it's terrible,
it's really hard work, isn't it?
Really hard work, yeah. So anything that sticks out into the air is bad, and we've even done work on these bits of the wheel that sticks out, and you can have some special aerodynamic nuts there. And then you've got losses in, say, the chain, the crankset, and so you've got bearings here which you try and make as efficient as possible. And generally they're about 98% efficient, all the bearings in the wheels and in the cranks. Lastly, you can stick one of these on the cyclist if you want. It's got a nice aerodynamic shape. You can see there that you've got something at the front, so the air hits the front and comes around the side. Follow these streamlined shapes, and then this point here causes the airflow to go down the back and reduce the size of that wake.
Is that tricky though if you're trying to look around and see what's behind you?
Yeah,
Does the
it's
point
not
get
so
in the
good
way?
as you're moving your head. If you're having someone following you in, say, a pursuit, it's very difficult to turn your head. So you look at Sir Chris Hoy, and he's got a helmet that's a bit truncated, so they've chopped this bit off at the back because it's more important for him to be able to see his enemy, so to speak, than to have those those low drag values with this helmet.
Sir Chris Hoy is one of several iconic track cyclists who create sporting spectacles as they hurtle around velodromes at speeds of up to 70 kilometres an hour. I asked Steve how the bikes used by these cyclists are designed especially for track racing.
The principles, the physical principles for track bikes and road bikes are the same, but of course they're optimised for the velodrome. For a start, they only have a single crank, which is optimised for that particular athlete and that particular athlete's power, and the cadence with which they can apply the power to the crank and onto the wheels and then onto the velodrome itself. So the bikes have the same principles, they're aerodynamic, but they might be stiffer because the forces at the start, when you think of Sir Chris Hoy pulling on the bicycle frame at the beginning, there's some huge forces involved there.
So you think, looking to the events this summer, I mean, do you think any records could fall in the track events?
Yeah, we could definitely see some world records being broken. We've got some very strong teams coming to the Olympics this summer. One of the tricks we use to increase performance is to increase the temperature of the velodrome, because if you increase the temperature of the air, that reduces the density and that allows you to travel subtly faster. So we might see some world records appearing this summer.